So last time we defined the gradient of a function, right? So recall, if you have a function, let's say w is the function of three variable. I am talking about three variable. The same you also work for two variable. So let this is a function of three variable. So then the gradient of that function we denote by del of f a comma b at the point a comma b comma c is defined by we have to take partial derivative at that point. So let's say I'm saying it p I cap plus del f del y at the point p j cap plus del f del y at the point p k cap. So where p equals to the point a, b and c. Right, Mayan? We did it last time.
Yeah, right.
So, yeah, very good. So this is called the gradient vector. And we have seen the geometric significance of this, right? So that also we have seen. So what was it? So if you take a surface, of course, the level surface, let's say you are taking, you have the level surface f x y g equals to c. Then, if you consider the point p on the level surface, then you will get a tangent plane at that point. So the gradient will give you the normal vector at that point. So let's say this is the gradient of f a b c. Now using this normal vector, we can write down the equation of the tangent plane, right? So equation of tangent plane was what? Equation of tangent plane is basically given by last time we did that x minus a comma y minus b comma g minus c, that dot gradient of f at a b c equals to 0. So this will give you the equation of tangent plane at the point a comma b of the level surface. And also you can write down the equation of normal line. So the normal line mean a line which is perpendicular to the tangent plane. So it is how given by, so symmetric equation I am writing x minus a by del f del x at the point a. So let's say p y minus b del f del y at the point p and g minus c del f del g at the point p. Man, okay?
Okay.
Right, right. So let me give you a question. You will try that. Just you will write down here. I'm telling you a question. So this one, give me a second. So yeah, so this. So here it is. The question: find the equation of tangent plane and normal line at the point, let's say 1 comma 1 comma half of the surface of the paraboloid. Let's say the surface has a name paraboloid, and it is given by g equals to 1 minus 1 over 10, right? So 1 minus 1 over 10 x square plus 4y square. Man, can you see the question?
Yeah, I can see it.
Okay, can you read it please? Then we start solution.
Yeah. Find the
Mhm.
that's equation, right? Find the equation of tangent plane and normal line at 1 comma 1 comma 1/2 of the paraboloid
G equal to
z
this.
equals 1 minus 1/10 times x squared plus 4y squared.
Exactly. So how we do this? So first we will, write everything we will bring to the left hand side, right? So the solution, and then we construct a function. So here the solution. So see, G equals to, you have 1 minus, I'm just distributing 1 over 10 with both terms, so then you get x square over 10, then it will be minus 2y square divided by 5. So what you do, just you take everything to the left hand side. So G minus 1 plus x square by 10 plus 2y square by 5 equals to 0. Now see, Mayan, actually the tangent plane and normal line to this surface at this point mean we have to consider this, the level surface of this, right? So you have to consider this function f x y g. Man, clear?
Yeah, fine.
Yeah. All right. So everything we take to the right hand, left hand side, and make the right hand side a constant. Here it is 0. So you can also take one to the right hand side, this one to the right hand side, but it's okay. You can make the right hand side 0. Everything you can take to the left hand side. Okay. So you consider your function is now f of x y g equals to what? G minus 1 plus x square over 10 plus 2y square over 5. So first we calculate the gradient of this function at the point 1 comma 1 comma 1 over 2. Mayan, okay? Always you have to
Fine.
write down, yes, this function, then calculate gradient. So the gradient, yeah, of this function at xyg, we know how it is given. So we have to take del f del x partial derivative of f with respect to x, then I cap, del f del y, then j cap, and del f del z, then what should we get? We get k cap. Man, is it okay?
Yeah.
So now tell me del f del x. Can you tell me what is del f del x? F is this function. Here f is given by this. Can you tell me what we get del f del x? Take the partial derivative of this expression with respect to x. Yeah.
Yeah, so it would be z minus 1 plus
Mm,
2x
yes.
um 2x over 10
So
plus
yeah.
y squared over 5.
No, they are constant. If you take the change of, because when you are taking change with respect to x, this means g constant, 1 constant, y constant. So the derivative of the constant are 0, right? Did you understand what I'm saying?
Yeah,
See,
yeah,
yeah, del f del x, if you calculate, so then you have to take del x of g minus 1 plus x square over 10 plus 2y square over 5. Now see, we are taking partial derivative of f with respect to x. This means except x, all other variable treat as a constant, right?
right.
So this is constant, so derivative 0. So 0, then minus 0, then here you get 2x over 10, and then you get also here 0. So this is nothing but x over 5. Is it okay, man?
Yeah,
Okay. All right. So del f del x is x over 5. So put it here. What about del f del y? Can you tell me del f del y? Del f del y. Now with respect to y, do it. Are you trying, man?
Yeah, I'm thinking.
Okay, look at this expression. You have g minus 1. Look at this expression. Your f is this g minus 1 plus x square by 10 plus 2y
Oh, it
square
just
by
turns to
2.
zero. Okay. I
Yeah.
think I get it. So
Hmm.
del f del y is 0
Yes,
minus 0
yes,
plus 0
yes.
plus 4y over 5.
Very good. Nice, nice. So we are getting 4 over 4y over 5 j cap. Now, can you tell me del f del g will be what? Del f del g. Now, with respect to g, if you calculate, then do the same thing. Now, x and y constant.
Should be
Hmm.
z. Oh wait, no. So 1
1.
minus 0
Yeah.
plus 0 plus 0.
Yeah. So you are getting 1. So just k cap. So let me do it here. So we are getting the gradient vector of the function f at the point x, y, g is given by x over 5 I cap, 4y over 5 j cap, and plus k cap. Whenever they will ask you find tangent plane and normal, first you write down the function, then you calculate the gradient. These are the step. Okay, Mayan?
Okay.
Right. Now, at which point do you want? We want at the point 1 comma 1 comma 1, right? This point 1 comma 1 comma 1 over 2. So now let's calculate this gradient vector of that point f of 1 comma 1 comma 1 over 2. So this means we put x equal to 1, y equal to 1, g equal to 1 over 2, right? Right, man? We put x equal to 1, y equals to 1, g equal to 1 over 2, right?
Right.
So if you put it here, then what should we get? 1 over 5 I cap. Then if we put here, in the place y1, then what should we get? We get 4 over 5 j cap plus k cap. Is it okay?
Yeah.
Okay, very good. So give me a second. So this is the gradient vector, right?
Yeah.
At the point 1 comma 1 comma 1 over 2. Yes. So what will be the equation of tangent plane? So then equation of tangent plane, as I told you, equation of tangent plane, that is given by how you get. So basically you have to take, the x minus 1 comma y minus 1 comma g minus 1 over 2. Just I have used the point 1 comma 1 comma 1 over 2. So x minus 1, y minus 1, g minus 1 over 2. This the dot product with gradient vector at the point 1 comma 1 comma 1 over 2 will be 0. Okay, Mayan, clear?
Yeah, clear.
Right. So you have to remember this, and why it is, because the gradient vector is normal to the. I explain here basically the gradient vector seems normal to the tangent plane. So if you take any point on it, let's say x, y, g, it is the q point, let's say, then the pq vector will be perpendicular with the gradient vector, and pq vector is given by, so x minus a, y minus b, and g minus c. So that's why the dot product of this with the gradient must be 0. So just you can remember this way, that the equation of tangent plane at the point a comma b is given by x minus a dot y minus b g minus c dot gradient of f at a b 0, like that. Okay, so this is 1 minus y, this is g minus 1 over 2. So this vector dot, the gradient is what? 1 over 5, 4 over 5 and 1. This is 0. Mine clear?
Yeah.
So, and you know how to dot product defined. So 1 over 5 into x minus 1 plus 4 over 5 into y minus 1 plus 1 into g minus 1 over 2, that equals to 0. So now if you simplify, so then let me multiple both side by 5. Then we can eliminate the 5 from the denominator. So what should we get? X minus 1 plus 4y minus 4 plus 5g minus 2, 5 over 2 equals to 0. Okay, Mayan, clear?
Okay.
Right. So if you simplify, then you get the equation of tangent plane. If you simplify it. So let me simplify. Just I multiple both side by 5 this equation. So then we get this. This 5 cancel out. So only x minus 1. This 5 cancel out. So we get here 4 into this. I just take 4 with every term. So 4y minus 4. And then here 5. So 5g here we get 5. So 5g minus 5 over 2 equals to 0. Now if you simplify, what should we get? X plus 4y plus 5g. X plus 4y. So we should get here x plus 4y, right? X plus 4y plus 5g, x plus 4y plus 5g minus 5, and then we get minus 5 over 2. Minus 5 over 2 equals to 0. If you simplify, you get x plus 4y plus 5g. If you simplify, minus 15 over 2 equals to 0. This is the required equation of tangent plane. Okay?
Okay.
Yeah. Now let me write the equation of normal line. See what we know basically. If you look at this here, you can see that the normal line will given by basically, see, we have the tangent plane, something like that, right? And we have this here, we have a point A, B, C. This is the normal line. So this line is the normal line, right? We have here. Now we know we have the normal vector here. So that is given by the gradient vector. So gradient of F, A, B, C. So the symmetric equation will be what? X minus A. So that is nothing but del F del X at that point, del F del Y at the given point, del F del G at the given point, like that. So the symmetric equation of the tangent line is given by x minus A divided by del F del X, the first component of gradient, y minus B del F del Y, second component of the gradient, Z minus C del F del Z. Okay, mine clear? So
Yeah.
yeah, in this case, what we have, the point is given by 1 comma 1 comma 1 over 2. This is the point, and gradient vector at 1 comma 1 1 over 2, that is given by, already have, it is basically 1 comma, sorry, what was it? It was basically where I have written, so that 1 over 5, 4 over 5 and 1. 1 over 5, 4 over 5 and 1. So this is the gradient vector of the function at 1 comma 1 comma 1 over 2. So equation of normal line, as I told you how to write. Can you tell me how we write? Just compare with this. You have to write x minus A del F del X, y minus B del F del Y equal to G minus C del F del G. Can you tell me equation of normal line? You have this, the point is this, the gradient vector is this. Symmetric form. Can you tell me? So what we write? X minus what? X minus what? Man?
Um, for normal line?
Yeah, normal line. We have a point on normal
Um,
line, 1 comma 1. Yeah.
it's
Symmetric equation we are writing.
X minus x1.
No. See, look at this. Here. If you know the point A, B, C on the straight line, and if you know the gradient vector del f del x del f del y del f del g, then this is the equation, symmetric equation, right?
Yeah.
So how will you write x minus a? So x minus the first coordinate of the point divided by the first component of the gradient vector. Got it?
Oh, okay.
So tell me now here.
So
Yeah.
x minus x0 over
No.
a.
What is x0? What is x0 here?
X0 would be
Hmm.
1.
Yeah, x0 would be 1. Yes. Then divided by what is the first component of the gradient vector?
A.
No. First coordinate of the gradient vector. What is
Oh,
the here? Look at this. In our situation,
del f over del x. So
del f del x is what?
um
We have the
1.
gradient. No. Look at this. You have the point here. 1 comma 1 comma 1 over 2 gradient vector is this 1 over 5 4 over 5 and 1.
Oh, okay. Wait, how'd you get 1 over 5, 4 over 5, and 1 again?
Again this from here we calculate. We
Oh, we
had the
already, yeah.
function. Yeah,
Okay.
we did already here, right?
Okay. Yeah, that's fine.
Okay.
So then, yeah, 1/5. So just 5x minus 5.
Yeah, then 4/5. Then g minus 1 over 2 and here 1. Got it?
Yeah.
So this is the symmetric equation of normal line. Okay, Mayan?
Okay.
Did you forget the about the equation of line how you write? See, if you have a straight line,
Just normal line. I forgot what that meant.
and if you know a point on it, let's say x naught, y naught, g naught, and if you know a vector parallel with it, let's say m vector having component a, b, c, then equation how given by symmetric equation x minus a divided by x minus x naught divided by a, y minus y naught divided by b equal to z minus z naught divided by c, this way, right? So
Yeah.
okay, normal line mean what? Normal line mean you have a surface, you have a point on the surface p, and then let's say this point p. So here you have the tangent line, I mean tangent plane. This is the tangent plane, right? So
Correct.
yeah. So the normal, the gradient will give you. So normal line mean a line perpendicular to the tangent plane, right? Passing through the point P. This is the tangent plane at P, and this is the normal line at the point P. Mayan, okay?
Okay.
Yeah, normal line at P. Yes. Now you have the situation. Now see, already point is given. The point is given by A comma B comma C. Here, for example, here we have given 1 comma 1 comma 1, right? So let's say here it is A x naught y naught. This point will be given to you, and just using gradient. If you use the idea of gradient will be a vector that is perpendicular to the tangent plane at the point P. Okay. So
Okay.
you get a vector here that is the gradient of f at a b c. So just using calculus, we are calculating this vector, the gradient vector, that is normal to the tangent plane. I mean, it make right angle with the tangent plane, and so it is parallel to the normal line, right? Mine, is it clear or not? Because you will get a question from here.
Yeah, this is fine.
Okay. So let me go to the next concept. The idea is basically, so now we consider a situation. Suppose we have two surface. Okay, Mayan, and they intersect. We have two surface and they intersect. Okay.
Yeah.
Okay. Intersection of two surfaces. Now the question, if you take two surface and if you make intersection them, what should we get? What should we get? Yeah.
Um, a line
Okay. So see, for example, if I give
of two
you,
surfaces, meaning planes?
no, it can be sphere, it can be paraboloid, whatever.
Oh,
So let me tell you 2, 3 examples. Then you understand how the intersecting looks like. Okay. If you intersect two surface, then how the intersecting part looks like, I'm explaining with 2 example. Okay, Mayan?
okay.
For example, yes. For example, if you take, let's say you have two plane and they intersect. Suppose we know they intersect, then what happened, Mayan? So what you get here? So if they intersect, then they will intersect through a line, right? Got it?
Yeah.
Okay. So if you take pi 1 and if you take pi 2, then this line, this is intersecting line. Okay. 1 second. So this is intersecting line. Very good. Mayan, are you sure two plane if intersect, they will intersect through a straight line? Are you sure?
Yeah, that's fine.
Very good. Okay. Now let me take a sphere. We have a sphere. Let's say this is a sphere and this kind of thing. 1 second. So we have here a sphere. Let's say this is the center of the sphere. Now, if I take the cross section of this sphere by a plane, so we are taking sphere and plane, intersecting of the sphere and plane. Okay, Mayan?
Okay.
Then what should we get? With the intersection part will be a circle, right?
Yeah.
Okay. So you know, when we took two plane, they intersect through a straight line. When we took one sphere and one plane and find out the intersecting part, we are getting a circle. So in general, if you take any surface, for example, if you take paraboloid, so let's say you are taking something like this, right? This way. Okay, Mayan? Now,
Okay.
yeah, if you take, the plane like this, so your plane is here. So then what should we get? We get basically the intersecting part will be a parabola, right? Like this. Mayan, is it okay?
Right. Yeah.
Okay. So if we take two surfaces, now someone can ask the question, let's say you are taking a sphere, you have a sphere here, let's say this, and let's say you are taking, let's say here, one more sphere. Got it, man?
Yeah.
This is looking little bit complicated, right? Then what should we get?
Yeah, kind of.
Yes, intersecting or intersection of two sphere. Then what should we get? We again get the intersecting part will be a something like a circle, right? This way. Mine is clear. Just it looks like
Yeah.
a circle. Yes. So this means if we take intersection of two surface, we are getting a curve, right? So intersection of two surface is a curve. This curve can be straight line, it can be circle, it can be parabola, it can be ellipse, it can be hyperbola, or any curve. Okay, Mayan? Mayan.
Okay.
Okay, fine. Now see here the question, we need to solve. They will give you two surface and they will give you a point on the intersection of two surface or on the intersecting curve. Then they will ask you write down the equation of the parametric equation of the basically the tangent line, or maybe equation of tangent line at that point of intersecting curve. Okay, mine. So they will
Yeah.
give you, they will give you two surface, and suppose they intersect along a curve. On that curve they will give you a point, and they asked you find the equation of tangent line of that curve at that given point. That we do. Got it, Mayan? Clear?
Clear. Yeah.
Okay. Just remember the method that I am doing here. So one question you will get from here also. So this is the question. So find, they asked parametric equation. Mine, how long time left for this link? Can you check?
Says 4 minutes, 40 seconds.
Okay, so then I think in the new link we do that. Okay, I'm sending you a
Okay.
new link because it will stop soon, right? Mine.
Yeah, you can send a new link. That's
Okay,
fine.
I'm sending you.
Okay.
Yeah, just sending. Bye.
All right. Bye.